To our main event, drones, a tool potentially to support occupational health hygiene professionals. Murray Ray is the presenter. Murray's someone I've only just met within our organisation. He's an inspector with our Bundaberg office, and also has a big interest in drones, for want of a better term. He'll explain that. He's quite a character, and he's a good ambassador for Workplace Health and Safety Queensland, with celebrating his 25 years with the department. So I might hand you over to Murray now, so he can get the session underway. Thank you.
I hope you can all hear me and see me. Thank the time to join me this morning. This is a first for me as well, presenting a webinar in this manner. It may affect my the way I naturally speak and flow, but I'll have a go. This webinar is about drones enhancing workplace health and safety. The aim of the session is to discuss the types of tech that are available to you, and perhaps excite you your thinking about how you could use drones to make your workplace safer or easier. Next. On this first slide, what is a drone? It doesn't tell you much, but I want you to look at it and read the title on the side of it. It's the first recorded example of an unmanned drone used, and it basically shows some balloons flying over a part of Austria, and the balloons are full of bombs, and as they get close, somehow or other, probably someone shoots a rifle at them from a boat or something, and they drop down and they blow up the land underneath them. That's the first recorded use of a drone. It was powered by the wind, and depending on which direction the wind blew in, some of the balloons sometimes turned back and landed with dire consequences on the people who had sent them. The use of drones, and even to this day, all the technological advances were a lot of them made by private companies, but they were aimed at or supported by military contracts and the need to keep soldiers safe and lots of reasons, surveillance and observation, all those type of things. So that's how a lot of the tech that we now got available to us in the technology that we can use in a workplace comes from some person that came up with a need and then thought, well, what can I do to realise that ability? There are so many different type drones out there. Most people think of drones as something that's flying and is probably horrible and evil, but that's not the case. Next. I'll go through the different types of drones. Balloons were the first flying unmanned recorded platform, and as I said, not so long ago, if you'd have thought about or asked the question, what was a drone, you might have thought of the military Predator drone. That's the one that you see on TV on some news report of it zooming in on a bunker in the side of the hill, or a vehicle making a getaway across the far distant land. And you would have all remembered that tense moment as the newsreel was playing where the drone's weapon honed in on its target and then boom, it blew up and there was this little crosshair on the page. what most of us may not have noticed, that we could count the people in the vehicle thanks to the drone's thermal imaging system. We could all see lots of other useful data in that image that was being sent back to a controller thousands of kilometres away, like in Germany or America or wherever. And they normally sat in a little container somewhere on a couple of joysticks in front of a TV screen. That advancement is what has allowed us to use drone technology. The pictures in the screen above are of what we call ROVs. So it's not just a drone. There's a lot of them. There's called Rovers, ROV, Rovers, drones. There's balloons, which I spoke about briefly. I just want to tell you a little story about the drone. It's actually the green one in the bottom of the image. Most of them have data collection sensors, from cameras to ultrasound thickness capability. They can sample sludge from the bottom of a tank or remove vermin. If you've ever been into one of those above ground water storage tanks, or the ones that are sunk down with a bit of tin over the roof, they get rats, they get bird nests, and all that sort of stuff can drop down into the water and cause all sorts of problems for the people who've got to drink out of it. Historically, people used to go into these tanks with full kit and 2 divers and air hoses and tanks, and that itself's a problem and a risk to the diver. And they would have had to have a support crew on the outside to, in the event of an emergency, or to feed hose in, or take the dead bird out of their hand as they held it up above the water. The drones, or ROVs in this case, are now actually extensively used. There's some water boards, one quite close to me, that uses ROVs in all of their tanks. This thing can just be, a fella goes up on top of the tank, or a girl goes up on the top of the tank, and they just lower this little thing down into the water, and away it goes. The engineer can be sitting back, in their desk at the head of the water board's office or somewhere, or in another part in the world, and they can see what the drone is actually seeing. They can guide the operator as the drone's doing the inspection. And for example, the drone might be whipping around the side of a tank where all the roof spars connect to the side of the tank, welded on, all that sort of stuff. And above ground, it can use its camera to zoom in on all those connections and fittings. It can detect rust. Some of them also have ultrasound capabilities on them. So as the tank's going, as the ROV is going around the side of the tank, it can actually take some sensitive ultrasound readings to the point where they can actually detect thicknesses of metal behind paint, which previously couldn't be seen. And then they can, the engineer could say, "Oop, I need to schedule that in for a repair or a patch or whatever." So the good thing about it is, before, with divers in the tank, there was communication issues. The engineer probably had to sit on top of the tank, and when the diver came up, the diver would say, "Oh, mate, I spotted this," or "Here's the footage." And sometimes it resulted in the tank having to be drained or taken offline for a couple of days while it happened. With the drone, it can inspect the tank in under an hour. So we've taken 4 people out of the picture, and I'm not here to bang on about loss of jobs and lots of stuff, but I am here to talk about taking 4 people away from being exposed to risk. We can have a more thorough and more precise inspection done of the tank, or the underwater pipe, or the outflow from a power station, or whatever the situation is that the rover is being used in. The last image we talked about, the green ROV, that's the one at the bottom right hand side of the page. There's a bit of a story about it. I actually got to talk to the operators when I was asking permission to use that their pictures in my presentation. This particular company was asked to send their rover 170 metres down in Sydney Harbour and release a buoy that sits on the bottom of the harbour and measures flow and sand build up and whatever else, water quality And originally it was designed that they'd shoot a sonar sound at it and it would release its mooring and float to the top. Well, unsuccessfully, it didn't work. So they engaged this company, and this company sent their rover down fully autonomously. And when it got close, they actually took control of it. Well, on the way down, its cameras were scanning everywhere, and they found a World War II shell casing that was probably, would have to be, from the images I saw, about 1 metre long, sitting on the bottom, just below the shipping lanes. And that drone there, the green, was actually able to attach like a sling type thing around it, using multiple grabbers that comes out from the bottom. And the Australian military were actually able, Navy were actually able to retrieve that and remove it to a place where it was safe to detonate it. So that's just one of the things that an ROV can be used for. Of course, they can take water samples, mud samples, sludge samples. They can take images. They can use sonar. There's so much that a drone can have hanging off it. Next slide, please. Hold on, I'm just catching up with my slide. So, okay, the next type of, I'll use the word drone, and there was a definition of what a drone was, but it doesn't fit any of these vehicles I'm showing you now. In the slide you've got in front of you, we call them rovers, and they're terrain-based. Some are autonomous, meaning they can run around the place doing what they need to do, and they can use sensors to limit or extend their activities, like sonar. This little rover up the top there has sonar fitted to it, and as it goes ahead, it can detect things in front of it, and it's smart enough with the onboard systems it has to maneuver itself around those objects and keep going forward. Originally, you might have seen a movie that was set in space or in some military action film, and the rover was being used to disarm or detonate a bomb, or take a sample of moon rock. We've all seen them. Science fiction. Rovers are typically deployed in spaces that are hazardous to humans. That's what we've got to think. So it's all about taking the human away from the harm. And that's what rovers, drones, are really good at. One example I'm aware of was an organisation that used tethered and untethered drones to inspect the drainage system underneath our highways and access points where people go through for data communications. If you ever get a chance to go under some of our major highways, particularly in Queensland, can't talk about the rest of the states, but there's a vast network of tunnels and drainage systems and communication conduits that run underneath our tunnel. There's even possum paths, where a little possum or koala can sort of skirt across. Well, accessing some of these areas posed problems for the tech that was around at the time. It placed limitations on its use, such as wide inspection cameras and gas detection devices. They had to drag along a really long cable in the old days to get that data back from the rover to the person that will be sitting on the side of the road or in the middle of a culvert, watching this little screen and trying to worry about, am I going to get hit by a truck or whatever the risk was. So in the olden times, there were, when I say old, not too many years ago, there were times when sections of major roads had to be diverted for the safety of the team that was performing the subterranean or below ground inspections. It was pretty dangerous sort of stuff. If you've ever gone to a construction site on the side of a road, you're always sort of watching your back at every moment, particularly if there's some sort of traffic flow through that area. Look, change was on its way, and it began when one industrious person, and this is a person I got to meet at a technology session a couple of years ago up in Bundaberg, and he was from a government organisation. He told me a story about how he bought his son one of those, remote control cars, the $50 ones that you get from Toy World or something like that. And he said, look, it was predictable that his son's interest in the car waned, and probably because he wasn't able to fix it fast enough. And for lots of things, the cost of the batteries, and Dad couldn't repair it in the end after it had been smashed up too bad. Super glue only goes so far when you're trying to repair things. So Dad started to see the potential for a new way of carrying a high resolution camera or a gas detection sensor further into the drains. He started experimenting using the toy type drones to see what he could do with them, using them in the tunnel systems and pipes and like that run underneath our highways, culvert inspections, and what it enabled him to do when he first started was do it from the side of the road at an access hole or from a safe distance off the side of the road where he and his mates were safe. It completely removed the operator from the risk of being hit by vehicles, and the interruption to the road network. Sometimes they had to shut roads to do these. You roll down on one of the major roads here in Brisbane, you go, oh, what's the traffic hold up now? And you can't see nothing. Could be because some guys, working on a inspection pit. Yeah. But the organisation he worked for immediately saw the benefits. And now that government department itself has a crew of guys that purpose-build drones and rovers to do just exactly what he brought to that organisation with his son's toy drone that cost him $50. And it was driven by the need to protect people from harm. And it's one of the reasons why drone use has moved on. It's not just something that's off the shelf. It's something that's purpose-built. And they're building drones and rovers that you can hang anything off. If you've got an imagination, you can put it on a drone, a type of drone. Next slide, please. In this slide, you'll see some examples of various types of drones and uses. For example, in the middle of the page on the left, there's a red and white helicopter. It's made by Yamaha. And in this image, it's being used for orchard spraying. That drone can lift 60 kilos, straight up, as long as it's centered, 60 kilos. And it's got big arms on the ground, it lands on the ground, and it can fly at humongous speeds. Can also do a lot of damage if it gets out of control. The drone down the bottom on the right-hand side, the fixed wing one, it looks like a toy. It's actually a really technical survey drone. It can count how deep or calculate how deep that hole is, how much soil's come out of it, how much soil it would take to fix it. It can survey all the access roads. It can detect different ore lines in the side of the hill. It can say, yeah, it's going to be about this much, inch or two, whatever, of an ore body. Very clever drone. It can stay in there for a long time because it's has lift as it flies forward. As a drone, opposed to a drone, the drone only creates lift by the 4 or 8 motors or 16 motors that are keeping it up in the air. You can fit cameras, radar, LiDAR. You can do so many things. I went to another technology display in Bundaberg. We have lots of them up here. The agriculture unit, Bundaberg Fruit and Veggie Growers Association, invite people, and just like the Australian Institute of Occupational Hygienists invite specialist speakers, they do that as well. I went to this show, and as I walked into the pavilion where it was being held, mind you, there was lots of tech in there. There was this little robot that looked something out of Star Wars, and it was smart. It would actually go up to a capsicum bush and pick the right one and pluck it and place it in a box and move along, and it could do it at night, 24 hours a day, and it would pick the right ripeness or colour, it cut it at the right place. It was a proof of concept made by a guy for the local university up here. It was made out of everything from Bunnings, absolutely everything on that drone. All the mechanical parts, the tubing, the belts, the wheels, all come from Bunnings. Okay, I met a guy named Nathan there, and he had a big drone, an Octagon, with 8 engines, quite a big monster, probably about 1.5 meters wide. And I was immediately drawn to it because I'm a builder as well. I don't know whether you can tell from the drones in the background. I love building them and designing to do certain things with them. So I felt quite happy going up to Nathan because we were both builders and I could start a conversation with him. You know, I from memory, the conversation started something went like, "Hey, did you build it yourself?" Or "What size motors do you use?" You know, "What's that chute hanging below?" And in drone talk, drone size does matter. So yeah, there you go. Why this drone was so amazing to me is that it was conceived and built to tackle a specific problem. Nathan explained to me he had thought to himself, you know, he's an ex-strawberry grower, and things got too hard. And while he was doing the strawberries, they had to manage the bugs, you know, all the little wasps and thrips and things that get into the strawberry plants. And he got onto a company called Bugs for Bugs, and that's not a plug, but they're the only ones I know of that do it, that sell the larvae of beneficial bugs, you know, little wasps and lady beetles, and you spread these larvae all over the acres and acres of strawberries by hand, and then when these little larvae hatch, the bugs come out and eat like copious amounts of these bad bugs, you know, the ones that eat holes in all these plants. And he'd done that by hand. Him and his wife and kids had gone out there, you know, little microscopic things that you can hardly see, spread them all over there. And it was a hit and miss process. So he came up with this drone. He built it because he thought a drone might be. He'd never flown a drone before in his life, and he built this great big monster. He built the drone, and then he had to come up with a way to spread the little soft larvae from the drone. You know, if he just had a chute, they'd all go splat on the ground, and half of them would be non-viable, and that was an expensive way to do it. Nathan explained to me sort of the different approaches that he tried. You know, he had a little flap that opened up. He tried to use the downdraft of the propeller on the props to spread them out, and none of it was successful. They got damaged. They didn't stay where they were supposed to stay. Well, he not took B to one to give up. He thought about, well, okay, if I make them a bit heavier, they'll be able to be dispersed a bit further. How can I do that without damaging the larvae? Well, this clever little bugger got this sand-like sort of mix that they call vermiculite. It's just like you mix it up like a really fine sort of creamy paste, and then he got the old mix master out and put the larvae and all that in there and this vermiculite and shook it out until you just had this little vermiculite fine layer over the top of these miniature little larvae. Some of them, you'd be bare with my eyes, I wouldn't be able to see them, you know. And then you had them tested, and these larvae were still viable inside this little outer coating of the vermiculite. It actually gave them protection. When they what's the word I'm talking about? When they eventually came out of their larvae stage, there's a term for it, but I can't remember. They were able actually just to crack open this man-made sort of eggshell that was around them, and get on and grow and do what they had to do. How did he get them out? How did he disperse them to a viable sort of distance out from the drone? Well, if any of you ever put a lawn in, you would have heard about those little Brunnings lawn sort of things. You know, the little green thing that you fill it all up with all the seed, and you crank the bejesus out of it, and you walk around and hope you haven't missed anything. Well, that's exactly what he did. His wife asked him to go and get one, and this was at the period he was thinking about how would he disperse them. And as soon as he got it in his hand, hot little hand, the light bulb moment went on, and he thought, "You beauty, I know exactly how I'm going to do this." And he got one of those and modified it, put an electric motor on it, and put his little vermiculite covered larvae in it, and hung it off the bottom of the drain, and thought, "You beauty." But then he couldn't carry much, so he thought, "How can I do this?" And he did. You know, they got to fill this little thing up. Well, on this particular drone there, you see that black box hanging off the bottom of it. That's actually made out of silky tracksuit material. And he got the fibres of the material to slope down. And as he poured all this vermiculite covered larvae in there and hooked it to the bottom of the drone, the air from the top of the drone kept it sort of loose in that sack, and the little flingy thing on the bottom of it it worked perfectly, and he was able to get good coverage. The drone downdraft that comes off a drone spread, and he could get a reasonable spread, and the drone could do thousands of acres in a very short time, whereas before a person would have to do it for days on days, and the viability was gone. Look, that's one of the things that I respected Nathan for, was his creativity. This whole presentation on, you'll get it at the end, but this whole presentation is based on not occupational hygienists or miners or construction workers. It's about, doesn't matter what industry you're in, creativity. I'll start banging on about necessity is the mother of all invention. That's a key phrase in everything that I talk about. So anyway, there's a bit of a spiel about that drone there. The one on the right in the cage, on the right of the same image, it's got a cage around it. I'll talk about that one. That's a confined space entry drone. If you've ever been into the double bottom of a hull or in a boiler, inside a boiler doing an inspection, or smelly, horrible places that a person, and highly dangerous, you'd have to shut places down. That drone was developed in Germany, and there's a company up here in North Queensland that uses them because that's where a lot of the sugar mills are. That can fly into an opening 300 millimeters wide. It can still be controlled through multiple thicknesses of insulation and iron and steel, and it can still send data back to the operator. It can have sensors fitted to it. It can do gas detection. It has receptors on it that can actually, anything that comes in contact with it, it can keep a recoverable sample of, whether it's a build-up of soot or dust or whatever in the connection points around that cone around the outside of it. It measures this distance as it goes through somewhere, so that you can accurately, if the engineer is not sure of the area that it's in, it can accurately retrace itself using the plans of that boiler, and you can say, well, yeah, at that point it would have been here. It's such a clever little device. Why send a person into a room with a hazardous atmosphere nowadays? You don't have to. They can do it. You just open the 20 bolts around the inspection hatch and put it in there and say, go do your stuff. There's so much clever tech around, and the sensors that go on that. It's got infrared. It's got separate lighting system. The camera can be turned 360 and all the good things that you need. It's the data it can send back that makes that drone so viable. Everything we're talking about now is data, usable data. Okay, could I have the next slide, please? Okay, I've got some results back there. I've had 30 answers saying no, they've never used, and that's 83%, and 6 have said yes. So it's just gone up. That's really good. That tells me that tech is being used in industry. I'll get on to in a minute some of the barriers to using drones, and I'll do that by telling stories, because that's the best way I can sort of relate what is a barrier to drone use. But look, we'll move on. Oops, one too far. UAVs, unmanned aerial vehicles, commonly known as drones. The reason we don't like calling them drones is because they conjure up for a lot of people, particularly elderly people in no matter what country you are, the old predator drone about to drop a bomb or Big Brother watching you. All right. In the image that's on the in front of you now, there's 3 images in there. Mostly they're used for, like spraying applications, from pesticides to herbicides, They also are used for communication. If you look at the image on the bottom right-hand side of that slide, you'll see a couple of drones and a couple of harvesters down below them. Not only are the drones smart, but the harvesters are smart. And in places where communication is an issue, the drones can be a transmission or a satellite relay so that the harvesters can operate with autonomy. And not only that, the person flying the drones would have a whole series of cameras going. He'd also be doing gas monitoring to find out whether his harvesting or land leveling operation was creating environmental or exposing people to risk from dust, dust creating or hanging in the air. And so drones can be used for lots of things. We just have to be creative. And look, sorry for the pause there, but you can buy a drone and you've got a drone that might not even have a camera on it, and it can just fly around. What is it actually telling you? Absolutely nothing. Introduce a sensor, which is a camera, and it's starting to give you some visual feedback. Get smart with that camera and you can start to do like aerial surveying. You can do photogrammatics of sites. You can do calculations of volumes. Put a infrared sensor on it. You can start doing plant health. You can start, doing COVID-19 sensing of people that walk in your front gate with a drone because of the thermal capabilities of a camera. Another one in there is down the bottom, you'll see that drone dragging that little blanket, tick dragging. I didn't know it was a big problem, but there are places where, cattle stations and growers of feed grasses and things like that, where ticks are a huge problem for workers, for cattle. Previously, they used to get some little bloke and he'd sort of hold a bit of a flannelette shirt up and he'd walk down some random bits of the paddock and all the ticks would jump from the tip of the grass to the flannelette blanket, and then they go back and count it and decide whether they had an issue with ticks or not. And all too often, the people, the guys, the poor bugger that had to go out and do, I know it wouldn't be me, that had to go and drag this blanket across the grass, some would succumb to a tick fever type thing, the being constantly bitten and ticks gorging on them and that disease that it can throw through. So some guy had a drone. I wonder if a drone's capable of dragging a bit of that flannelette stuff across the paddock, and they are. The crucial point was the attachment point to the drone. If that bit of flannelette got hooked up on a solid bit of twig, would it pull the drone down into the grass? And yes, it did. So the clever part there was the attachment of a breakaway connection to the drone, so that at a certain sort of, the drone's flying along dragging this blanket, the blanket would actually pull away and the drone could fly off without any issues. You might have seen the same thing on drone fishing. That's how they stop a drone from being pulled into the water when it drops its hook. It's a little release mechanism. So look, it's amazing. Again, it's the data that comes from the drone use. In this case, how many ticks on that bit of blanket per 5 runs up the paddock, or how much volume of chemical did we spray across that crop, sweet potatoes or whatever it is there. You'll see 3 drones in that top image. That's amazing because all those 3 drones are flying as what we call a swarm. They all talk to each other. They all know where they are. They all know the coverage of their spray. They're smart enough to say, oops, my battery's going flat. So they'll fly back. The operator will change the batteries. It'll recommence the mission. It'll go back to exactly the same position and start that spray again until the whole thing's done. Having done it once, you just send the drones out there and you go, do mission 3, and it flies that paddock again and sprays that chemical or drops that powder, or it's what we do with the data. Could I have the next slide, please? Okay. Excuse me for talking about product names, but in this case, I will. In the image in front of you is a DJI Phantom 4. If for any of you have seen a Phantom 4, it's not a normal Phantom 4. It's got something fitted on the top of it, and I'll get to that in a minute. Look, we talk about smarts and technology, and I want to talk about the evolution of drones and jog back to where I said development of drones is based on originally military and all that sort of stuff. And then industry creates change, but for the big producers of drones like the DJI Phantom, and don't take me wrong, it is a really good drone, it's also a money-making machine as well. So the drone in front of you has got sensors on all sides, except for the top. Well, it's got one on it now. But it took 4 years for it to go from having a sensor on the front to a sensor on the back to a sensor on the side and the other side. And each year that you were forced to buy a new drone. It just reminds me of, a smartphone. Yeah, same functions, but an extra camera. Industry drives changes. Manufacturers manage money-making capabilities, so keep that in mind, all right? It's not a bag against DJI or any of the other companies up there, but people would buy one of these and go, well, what can it do? I've paid, $3,000 for a drone and it's got a camera on it. Yeah, because you didn't ask for a drone that was designed for what your needs, or you didn't know what you wanted to use a drone for, or what sort of data you were trying to collect. You can hang lots of things off those, 300 meters of fishing line with 6 hooks and bait on them. Sorry, that's irrelevant. But you can hang lots of things off them. You can hang loudspeakers, you can hang flashing lights, you can hang rescue buoys that blow up when they hit the water, and you can talk to someone that's nearly drowning while you drag that little floating rescue buoy across to them. You can survey. There is a lot of things you can do with a little drone like that there. The thing on top of it is RTK. It's a really accurate means of surveying. It takes a lot of the legwork and guesswork out of doing aerial surveying. So, and that's, cost about an extra $6,000 just for that little bob that sits on top of it, and a little rubber mat you put out in the paddock. That the ground is a ground reference for the drone's initial takeoff. Can I have the next slide, please? Oh, sorry, I'm just catching up slowly. Okay, this is a really interesting slide, and I'm going to have to bang through it because I've gone over my time, which I didn't think I would. So I'll talk to it, and I won't tell all the stories. The map in the middle on this image here, you'll see it. It's Vanuatu, and it's after the Cyclone Pam went through in 2015 and flattened it, and a lot of little islands around it. The important part about this one here is the use of drone and associated technology to survey those islands and the damage that was caused by the cyclone. You'll notice some different coloured buildings, red, yellow, blues. Well, the red ones were the ones that were destroyed. The yellow ones were the ones that were partially destroyed, and the blue ones were ones that could possibly be used for emergency shelters. All this was done within a very short time. 2 operators, one from Australia, one from New Zealand, were put on a military plane, flown over to the islands, and within 8 hours they'd flown all the major islands with a drone, and the AI that was on there was even able to count the number of power poles that were down. So when the aid boats came over, they would have 250 power poles and X amount of meters of cable. They would even be able to show where the roads were damaged. I'm going to have to skip on. Sorry for rushing, but that's my fault, not yours. So can I have next slide, please? Construction. Very simply, doesn't matter whether it's construction, mining, earth moving, farming, whatever. All drones have surveys on them and survey equipment on them. They can be used for on-site traffic management, scaffold inspections, surface water, roofing, gutter inspections. There are so many things that drones are used for. On that bottom picture, I took that image, and that was one of the days I didn't have a drone with me, so I took the shot from the bottom. I couldn't see what was happening on the other side of the roof. You may be able to see cables or what I thought was lanyards, but they're not. They're actually nozzles for spray guns. Can we please move on? Very quickly, drones as tools. What's in there? What is it? Look, so far I've discussed what is a drone. A drone is anything that you've got the initiative and the creativity. I've got a remote control lawnmower for my wife because she wouldn't bend down on the ride-on and go underneath the tree. So I made her a remote control lawnmower. That's a drone. She can watch it on TV. Again, necessity being the mother of invention, and reminds you that drones were initially developed to save human life. So, you know, the old soldiers, they didn't want the soldiers to die. We as safety professionals don't want our clients and their workers and us to be exposed to harm. So drones are a tool that can be used for that. May I have the next slide, please? Barriers, and I've run out of time and that's my fault, but most barriers to drone use come from ourselves. We talk about CASA regulations and the Workplace Health and Safety Act, and yes, sure, they all apply. And people go, oh, I can't fly that drone over my workplace and do an as-build because there's a CASA rules and there's a Workplace Health and Safety rules. Well, the drone is an aircraft, and once it's registered, you can put in a flight plan, just like any other aircraft that flies over any bit of airspace in the world, and you can fly at the airport if you want to. You can fly 2 feet away from the airport at the given time that you've told them that you're going to do. Oh, but I can't fly 30 metres close to a person. No, of course you can't. You never will be able to unless you meet a whole lot of onerous requirements. But you have control of the site. You can close the site, do it in the morning, do it at lunchtime while the workers are inside. You can have a safety spotter. It's your site. Fly the drone and say, guys, come back in now, it's safe, and make sure you've had your hard hat on, whatever. You have control. So yes, there are ways. We talk about safe work method statements and safety plans. It's just another element that you have to build into your safety plan. So yes, there are barriers. Some people say, oh, I bought a drone and it does nothing for me. That's because they never put some thought into what the drone was. There are barriers. Most of them are us. Legislation is not a barrier. Cost for most people is something they could build into their operating controls. They're not that expensive now. You can buy a Phantom 4 for $3,000 with a camera that will rival any digital SLR that you've got on the market on them. Next question, please. Next slide, please. That image you're seeing now is one I got given a long time ago by a gentleman that was, how should we say, annoyed at pilots complaining about, oh, drone's going to fly into my plane and all that sort of stuff. And that was put out as a bit of humour. Most people, they look up in the sky, they see something and they say, oh, it was a drone. It was near my place. Well, we all know better than that. So I'm going to go to the next slide now. Sorry, I'm a bit out of sync here, but I'll cap it off at the end. My closing thoughts, and I'll read this to you. My hope is that I've been successful in getting at least one of the message I was trying to communicate in the presentation across, even if it's the one I mentioned, you know, necessity is the mother of all invention, because that's the crux of this presentation and on how change comes along. We have a need and we design something to fill that need. I don't think I've mentioned the field of occupational hygiene once, or maybe once in this presentation, as it was not about the hygienist. It was about applying creativity on the back of a drone or on top of a rover. For example, I'm working on a design that will allow one of my drones to take a sample from of ACM from a roof or gutter without creating airborne particles. And while I wouldn't have to enter the removal area, you know, it's protecting me. And I've got another plan to go with that as well. I don't need to get gas samples or atmospheres in confined spaces, but I'm sure one or two of you lot will be asked to do that. So get thinking, get creative. How can you do that? is a drone appropriate? It might not be. Drones can fly in flammable. We can get intrinsically safe drones that aren't going to ignite a flammable area. So, look, here's a thought. What if some clever person developed some smart AI, artificial intelligence software, that was capable of identifying from a drone footage the different types of profiles ACM roof sheeting, such as Super 6 had? I'm sure some council department would be interested in that being developed to manage a suburb removal plan or something like that. It could be sold as a commercial. Look, thank you all. I apologise for the last part of it. My timing was wrong. I'll hand back to the coordinators. See you guys.
Thanks, Murray. We do have a couple.
Yes, I'm here.
If you can hang around for us. Beck has asked about propeller interference with the collection of maybe air samples or the mechanism, an active gas monitor. How do they?
I'm not the expert, unknown factor spurt the drip under pressure, but I have done a little bit of an ignorant person look at it on Dr. YouTube and Google and things like that. And just take that Phantom 4 drone, the white one with that little sensor on top of it. If you put the sensor below the prop wash, it's a problem. But if you put the sensor on top of the drone, on like a little extended arm up on the top of it, it actually funnels. Like, say you were going to do a methane gas detection on a smoke stack of a boat, one of the ocean liners that comes into our country. If you flew under the plume rather than above the plume, because if you're above it, you'd be interrupting the air around the plume. If you fly under it, it actually channels the particles and substances that are in that plume through a sensor before it gets to that turbulent air. So I hope that answers your question. They are available out there.
I might just wait if anyone else has any questions. Feel free to type them in. But while we're waiting, I'd just like to thank you very much for the presentation. Are you aware of any mining companies that may have adopted drones? And if any hygienists are a part of it?
There are many companies that in mining industry, particularly in North Queensland, up past Weeper and to the right-hand side, there's Comalco and the BHPs and things that actually operate up there. I was fortunate enough to watch a presentation on two of their safety professionals they have running up there. And yes, they have a team of 4 people and a fleet of drones and rovers that I would actually die to have sitting on my shelves. And I've got 13 out in the back room. But these people had some really good stuff. They have drones that have different samplings. They've got the Phantom 4, which is the one I mentioned in the image before, which is, hang on, I better go the right way, that little white one you see down there on the shelf over there. And on each of the arms, they have 6 gas-capable detection units, where they're the size of a little cigarette packet, excuse me, the diameter of a cigarette. They have a thing that big sat on each of the 2 arms of the drone, and along it there's 6 little receivers that take these different sensors, and they fly them into different dust. Pardon me. And I'm thinking, how do they do that? They actually use the plume, the prop wash of a drone. They go over there because not only do they look after their mining face in the underground, but they look after the land above it from an environmental point of view. So they'll get their drone over and check water troughs and fencing and security. And when it gets close to the ground, it creates this prop wash, and it actually refeeds dust back through these little samplers, and they get that drone back in, and they do what the magic they do on them, and they can say, yeah, well, it's lacking in this, or it's high in that, or we've detected lead in it, or so yeah, it's amazing. These people use. Look, Comalco is one of the ones I can talk about now and tell you that I know they have a crew of 4 people that use drones extensively. water settlement ponds and faces of open cuts and dust coming off the back of trains as it's going from the place it's mined from to the place it's going to be shipped out, instead of the old fixed ones that someone had to climb up and clear them and unclog them and all that sort of stuff. They have these on a drone. You haven't got people. Yep.
That's good information. What about actually flying a drone? What are the license requirements?
In Australia, CASA requirements are that if you fly a drone under 2 kilos, you don't have to be licensed. It's called the excluded category. If you fly for a hobby, you don't have to be licensed. You just have to have done an awareness session online, and it teaches some basic regulations, and you get a little piece of paper saying, yes, I've been made aware of the requirements for 30 meters and 120 height and all those type of things are important. To use a drone bigger than under 2 kilos commercially, you have to have a license, and they go in certain categories. I'm licensed for a 25 kilo drone. A 25 kilo drone is that one on the back wall over there, which is 850 wide from prop to prop or from motor to motor. With its total carrying weight, it's probably 7 kilos. So a 25 kilo drone, it's going to lift your dog off the ground, or 20 litres of spray, depending. And then as you get a license, it actually opens up a whole lot of avenues. Like I can't fly within 5.5 meters couldn't fly within 5.5 meters of a airport. A lot of building sites and things are happening. Industrial sites are happening around airports as the suburbs spread out. And lots of people thought they couldn't fly there. But with a license, you have qualifications, training, experience, maintenance, all the things that are good about safety on a drone. And it allows CASA to say, yep, this guy's or this girl is qualified, they're licensed, their machine is maintained, they've done a risk assessment, they've got high order controls like triple redundancy, 3 GPS. They'll allow you and give you a flight permit that you can get onto the tower and say, ARN number, blah, 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 blah. Oh, I'm going to take off from this location at this time. And they're aware of it. You repeat back their instructions to you. They let other aircraft in the area know. Or like me, you can get a radio operator's license so you can communicate with the tower. That's an extra bit that you can get. So yes, there are benefits to having it. Clients are more confident with a person that showed their competency and their professionalism with the drone use, and they're easy to fly.
That's good. One of the things that I know you do with workplace health and safety, what about drone use for asbestos surveys? Or
that was my final whip over where I ran out of time there. I do general inspection work and asbestos complaints are some of the things I get. You can actually take a sample, Zach, we do the old sticky tape on top of the fence rail and take the sample and send it away, and a drone can do that without disturbing the roof. On the opening image of this, you'll see a roof, an asbestos Super 6 roof. I used a drone to take a sample off that roof without disturbing, with an arm, which is like a flexible pendulum arm that goes out behind the drone. That you go up with the drone, you're 2 meters away from, you dab the arm on the top of the roof or in the gutter, and you remove it to a safe place. The arm lays down I'm facing away from the camera. As the drone goes to land, the arm goes back onto a plastic sheet. You take the sample off and you put it in the box. You didn't have to climb up on the roof of friable. Fat inspector me doesn't have to fall through a bit or hang off the side of a ladder. No one else is exposed to it. Most times there's a bit of dampness if you do it in the morning, so you're not going to, the likelihood of creating a airborne is minimised. That's what I talked about. Sorry.
All right, well, I've got one last question for you. So some of the things we might want to use drones for might be noise measurements. How loud are some of these drones?
I don't know whether you cook, Zach, but have you ever heard a mix master really going flat out trying to churn up some veggies, or celery or into a juice or something like that? Some of them are really, really loud. and some of them aren't. But you can actually use drones to do certain types of noise sampling. I've never tried it and never really looked back into it, but I'm told you can. How? I don't know. Filters or certain types of noise that can be detected above what or below what the drone puts out. I don't know, mate. Some clever people there use people do you know, sound and all that sort of stuff. Strap one on the bottom, mate, and see what you can do with it. Put some wind muffles over the you know, when we do our sound detection, we've got a wind cover over the top of the input for the mic. You can try it. Pose the question as a group to the local university and say, what sort of the noise is under the drone, not above the drone. Remember, all the noise is created by the downdraft pushes the noise away. So it might be possible to have a 1 foot carbon fiber boom on top of a drone. You can have a 6 foot boom on top of it. You may be able to get a detection device far enough away to the above a drone. Hope that helps.
Oh, that's very good. All right. I'd love to just thank you again, Murray. It's all really good information about drones, and I hope it does challenge people in identifying how these things might be used in
just before
thank you very much.
No, Zach, just before you do, if any of your members want a contact number, feel free to give out my mobile number and email address, and if available, mate, I can talk them through and help them on the way. Thanks, guys.
Lovely. All right. Thank you very much for attending.
I will get better. Bye.
We'll catch up again soon.